In order to play same piece sets in NES Tetris, we rely on a ROM hack TetrisGYM by Kuryava, which uses a set seed. The pseudo-random number generator has multiple flaws, but the one we're discussing today was actually played on April 14th, 2024. In order to get similar piece sequences as NES Tetris, TetrisGYM uses the same 16-bit linear feedback shift register, or LFSR, as NES Tetris. This is the core of its RNG, and it's bad. Its main benefit is that it's very fast. The algorithm only requires a right shift and an XOR, which is extremely efficient on the 6502 processor in the NES. This algorithm is run multiple times, but we'll get to that later. With most RNGs, there are weak values, and this is no exception for the LFSR. In TetrisGYM, those weak values are 0000XX and 0001XX. What happens when a weak seed is played? We see a repetition of pieces in the following sequence: ZOSLISTJ, ZOSLISTJ. The easiest way to determine from a sequence if your players are playing on a weak seed is LIST repeating, because LIST is a word. But if you're a restreamer, all you need to do is look at the first four digits of the seed and check if they're 0000 or 0001. Please do not play these seeds because they have no RNG component, and that is a critical component for competitive Tetris. Hydrant Dude gave a great explanation of NES Tetris's RNG, but because we'll need all that information, I'll be repeating the ideas step by step in the case of a weak seed. First, we run the LFSR algorithm, and to explain the LFSR algorithm in depth, it takes the 16 bits from the left hand of the seed, so that would be 0001 in a bad seed, and it runs the following algorithm. First, you XOR the 2-bit and the 32-bit together to determine the new highest bit. Then you right shift the seed. Then you combine those two. If you do this, you'll find that 0 and 1 both have the same outcome, 0. Therefore, any seed that starts with 0000 and 0001 will result in repetitive sequence. The next piece actually runs this LFSR multiple times in order to get a pseudo-random sequence. The number of times that it runs the LFSR is determined by the highest nibble of the last byte of the seed, so the third pair of hex digits. It's not always obvious how many times it's going to run, but in our case, which is simplified, it doesn't matter how many times you run the LFSR, you always get 0 as the result. So this curious system adds the first byte and the last byte of the seed and takes the modulus 8. If If it's not 7, it returns that piece from the spawn table and sets the spawn ID to the piece in the spawn list. So for example, if it rolls a Z piece, it will put 8 into the spawn ID. So that's how that works. If it is 7, then it re-rolls the LFSR and increments the last part of the seed again. Then it adds the first part of the seed to the spawn ID, then taking the modulus 7. Since the spawn ID of the eyepiece is 18, and 18 mod 7 is 4, we get S after I. This results in the predictable pattern we observe rotating through the spawn list in this strange way. ZOSLISTJ. Hopefully that makes sense and explains why we end up with this pattern whenever we use invalid seeds.